Hi students, most welcome to AT Sir Chemistry Pathshala, and we will discuss about chapter 4 chemical kinetics in one shot. So please watch this video completely and revise your chemical kinetics chapter. That is very important chapter to physical chemistry for 12th class students. And let's start. So, what do you mean by chemical kinetics? You know very well the branch of chemistry which deals with the study of rate of reaction is called chemical kinetics. And main important topic and terms or word for chapter chemical kinetics is rate of reaction. And what is the rate of reaction? You know very well. Change in concentration of reactants or products in particular time, or can be said unit time, is called rate of reaction. So rate of reaction formula is change in concentration upon unit time. So with the help of this formula you can solve the unit of rate of reaction. You know very well, concentration represented is mole liter inverse and time in second. So with the help of this formula, the unit of rate of reaction is mole liter inverse time inverse. With the help of this formula you can find out the unit of rate of reaction. That is very easy. So you know very well, average rate represented by RAV and instantaneous rate represented by RINS. For RAV use delta sign, and for instantaneous rate use D, differentiation D. It is INS use D, average use delta. Here means of R, reactant means of P, product. For reactant use minus sign, because you know very well, within time, increasing the time, the change in concentration of reactant get decrease and concentration of product get increase. So for decrease use sign minus, and for increase use sign plus. Okay, so now we will discuss about rate of law of active mass. Rate of law of active mass. This topic is very important. Rate constant and rate law, rate of active mass. According to Goldberg and Wage, the rate of any chemical reaction is directly proportional to the products of active masses of reactants participate in a chemical reaction. Here an example. A and B, A plus B is equal to product. A plus B is equal to product. So rate of reaction is directly proportional to concentration of A into concentration of B. So R is equal to K, A with active mass into B with active mass, and this R with the based on differentiation can be written as minus D concentration of A upon dt is equal to K active mass of A into active mass of B. So it is clear, you know very well. Proportionally constant, here K is known as rate constant. Another terms of this chapter is very important after rate of reaction, that is rate constant. Here K is proportionally constant, that is known as rate constant. So an important question for MP board and also for CBSE board, that is Write some important differences between rate of reaction and rate constant. So you know very well rate of reaction in a chemical reaction, decrease in concentration of reactant or increase in concentration of product. Rate constant, it is a proportionally constant in rate law expression. What is rate law expression? So please, this equation is rate of rate of rate law R is equal to K. So this equation is rate law expression. I hope. And please now state your topic. Second difference between rate and rate constant. Rate of reaction depends upon the concentration of reactant, but rate constant does not depend upon the concentration of reactants. It is represented by R. And it is represented by K. And unit, the unit of rate of reaction is mole liter inverse time inverse. Instead of time, you can say second inverse or minute inverse. But the unit of rate constant is depend on order of the reaction. So this is important topic. Next again, before the study of order reaction, all of you must study of the molecularity of reaction. What is molecularity? You know very well, in chemistry there are two types of reaction. First is elementary reaction and second one is complex reaction. What are elementary reactions? The chemical reactions which are completed in only one step, only single step, are called elementary reaction, and the chemical reactions which are not completed in only one step but completed in two or more than two steps are called complex reactions. So molecularity terms is applicable for only elementary reactions, but terms order of reaction is applicable for both elementary reaction and complex reaction. So molecularity is always a natural number, you know very well, and it cannot be zero or fractional. For example, first example, NH4NO2, molecularity 1. Second example, 2HI decompose into H2 plus I2, here molecularity is 2. 2N2O3, 4NO2 plus O2, sorry, here 2N2O5, this is correction, molecularity 2. And in last example, 2NO plus O2 is equal to 2NO2, molecularity 3. Next, order of reaction. What is order of reaction? We know that the rate of any reaction is determined by those molecules of reaction whose concentration change during a chemical reaction. Hence, the number of those molecules of reactants whose concentration change during a chemical reaction is called order of reaction. It is an experimental value because without an experiment, order of reaction cannot be determined. And an important point that order of reaction may be 0, fractional value, addition with 1, 2 and 3. You know order of reaction you can find out with the help of the rate law expression. It is rate law expression. Here X is the concentration step of A and B is concentration step of Y. So total order of the reaction X plus Y, and if only A, then order is X. If only B, order is Y. Total sum of order reaction is X plus Y. So with the help of rate law expression, you can easily find out the order of reaction. So now we will discuss about how to determine the order of reaction. It is important for 1 marks and 2 marks question. Calculate the overall order of reaction. R is equal to K A power 1 by 2 and B power 3 by 2. You know very well order of reaction. Sum of power of concentration of reactants, so can be said X plus by. So here X is equal to 1 by 2 because the concentration of A 1 by 2, concentration of B 3 by 2, powers sum showing. So 1 by 2 plus 3 by 2 is equal to 4 by 2. Hence this rate expression is represent second order reaction. And you know very well with the help of order of reaction we can find out the units of rate constant. Units of rate constant is very important topic. So for finding out the units of rate constant, for any order of reaction, use concentration upon time into 1 upon concentration power n. Concentration upon time into 1 upon concentration power n. Here zero order of reaction 0, and concentration use moleliter inverse, time use second into 1 upon moleliter inverse power 0 value 1, so cancel out. Hence moleliter inverse second inverse. First order same as instead of n use 1, second inverse, second order mole inverse liter second inverse, third order mole inverse to liter square second inverse. So please all students practice and more practice for finding out the rate constant. Units depend on 0, first, second and third order reaction. And this question 18, please solve this. Now we will about discuss difference between molecularity and order of reaction. It is an important. Molecularity, the total number of molecules, atoms, ions of the reactants in a chemical reaction is called molecularity. And the order of reaction, you know very well, the number of those molecules of reactant whose concentration change during that reaction is called order of that reaction. Second, molecularity is always integer natural number and it cannot be zero and fractional. Here order of reaction, it may be 0, you know very well, or fractional value also know, and except with natural number means order of reaction may be 0, may be fractional, may be negative, may be 1, 2 and 3. Third point, it can be find out for, here is wrong, it can be find out for only elementary reaction, you know, only one step elementary reaction, and it can be find out for both elementary reaction and complex reaction. Fourth difference, molecularity side, it can be determined from a balanced chemical equation. And important, you can find out the molecularity with the help of a balanced chemical equation. Here it can be determined by an experiment. Without experiment, order of reaction cannot be find out, because with the help of experiment we can find out the rate law expression. And rate law expression, you know, the sum of powers of concentration of reactants is equal to the order of reaction. And in last, it is a theoretical value. And it is experimental value. Okay students, so next integrated equation. During about integration of rate law expression, we can find out the integrated equation for zero order reaction and also for first order reaction. Zero order reaction, also for first order reaction. Zero order reaction, zero order reaction. Please wait. This zero order reaction, K is equal to R naught minus R upon T. Here R naught is initial concentration of reactant and R is final concentration of reactant upon time. And integrated equation for first order reaction is very important, very important. So please learn it. K is equal to 2.303 upon 2. Sorry, T. K is equal to 2.303 upon T log 10 R naught upon R. Here R naught same for zero order reaction, that initial concentration of reactant, and R is final concentration of reactant. So please, this formula should be learned for finding out the half-life period for zero order reaction and also for first order reaction. So dear students, for next video please subscribe my YouTube channel and please press the bell icon for next video. And if you like this video, please press the like button. Thanks. And remaining part of this chapter will be shown uploaded at my YouTube channel AT Sir Chemistry ki Pathshala. Thanks.